Let's talk about methods to reduce alkynes. A lot of the reactions that we see with alkynes are very similar to the reactions that we see with alkenes. For example, catalytic hydrogenation reactions will add hydrogen across a pi bond. Notice that it says a pi bond and not an alkene. Pi bond is pretty open, which means you can reduce other pi bonds with catalytic hydrogenation. In a catalytic hydrogenation, you could take an alkene, it'll add 2 hydrogen atoms, and we have an alkane. This is the same if we have an alkyne. An alkyne, if we subject it to catalytic hydrogenation, will be reduced all the way down to an alkane. What if we wanted to stop at this stage where there's an alkene instead of an alkane? What if we did want to go all the way down to an alkane? Well, what we can do is we can take this metal catalyst and we can poison the catalyst and make it less reactive. One example of that is Lindlar's catalyst. When we use Lindlar's catalyst, it's very similar to a catalytic hydrogenation, and we will take an alkyne and we will end up generating a cis alkene. Notice these two methyl groups are on the same face. This is because during a catalytic hydrogenation, the pi bonds will sit down on the metal and the hydrogens will transfer from there. You can look back at our original catalytic hydrogenation tutorial if you're not sure about all of these details. How do you poison the catalyst? Well, a lot of times nitrogen atoms can kill the reactivity of palladium. Lindlar's catalyst specifically takes quinoline, this aromatic group here, palladium attached to some barium sulfate in a solution of methanol. Alternatively, if we didn't want a cis alkene, we could generate a transalkene. We can do this with a dissolving metal reduction, where you take solid sodium metal and ammonia. This will end up generating the trans alkene instead of the cis alkene. This follows a radical mechanism that is beyond the scope of what we're talking about here. So to summarize, catalytic hydrogenation reactions, just like in the case of alkenes, will reduce alkynes all the way down to alkanes. If we poison the catalyst and use something like Lindlar's catalyst, we can reduce the alkynes down to alkenes, in this case the cis form. Finally, if you use a dissolving metal reaction, you can reduce an alkyne to the trans alkene.